This session is a continuation of the Chapter 1 review, starting with Problem 12. Problem statement says the endpoints of a segment are given. Find the coordinates of the midpoint M. So here we have, for 12, endpoint E is negative 412 and F is 315. Now the midpoint of a segment is always going to be the average of the coordinates of the endpoint. So in this case, since we're on an XY plane, what we want to do is we want to average the X coordinates first and then average the Y coordinates. So let's get started here. For number 12, our midpoint is going to be negative 4 plus 3 over 2, the average of the X coordinates. And the Y coordinate is going to be 12 plus 15 divided by 2. So to figure this out, negative 4 plus 3 is negative 1. So this is negative 1 half. And 12 plus 15 is 27 halves. And that's the midpoint of EF. Problem 13 is the same thing, just different coordinates. So for 13, the midpoint is the average of the X's. So that's 9 plus negative 1 divided by 2 and negative 6 plus 8 divided by 2, which is 9 minus 1, which is 8 divided by 2, and negative 6 plus 8 is 2 divided by 2, which gives us 8 divided by 2 is 4, 2 divided by 2, 1. So our midpoint is 4, 1. Now we move on to problem 14. Problem 14 says the midpoint of segment JK is M, 6, 3. One endpoint J is 14, 9. Find the coordinates of the endpoint. So this is still an endpoint problem, but we have one endpoint and the midpoint. We're looking for the other endpoint. So graphically, I'm just going to represent this as a segment. So let's just put a segment in here. And we're going to call this endpoint down here, we'll call that J. And that's at 14 and 9. And our midpoint will be here, and that's M, and that coordinate is going to be 6, 3. And this point is the endpoint we're looking for, K. We don't know what coordinate it is, so we're just going to call this X, Y. Now again, this is still a midpoint type problem, but we're given the endpoint, and we're given a midpoint. So we know that the midpoint, 6, is the average of the endpoints. So the average here of 14 plus X. 14 plus X divided by 2. So the midpoint, 6, the X coordinate 6, equals the average of the X coordinate endpoints. Now that's all I have to do is solve for X. So we're going to multiply both sides by 2. 12 equals 14 plus X. And then we subtract 14. So negative 2 equals X. Now we're going to do the same thing with the y-coordinate. So the y-coordinate of the midpoint, 3, equals the average of the y-coordinate of the endpoints. So 9 plus y divided by 2. So here again, we multiply both sides by 2. 6 equals 9 plus y. Subtract 9, negative 3 equals y. So now we know the coordinates of our endpoint is negative 2, negative 3. Like I said in the beginning, it doesn't really matter how this is organized. It doesn't matter if they're in the wrong place. This is the other endpoint of this segment. Okay, so now on to problem 15. Problem 15 says, point M is the midpoint of segment AB, where AM is 3x plus 8, and MB is 6x minus 4. Find the measure of AB. So here, we don't really know if this is diagonal, if it's on a number line, so we're just going to, for simplicity's sake, we're going to put this on a straight number line. So here's our segment. Now let's go ahead and put in our points. So point A, let's make point A here. Point M is the midpoint, so let's put that here. So this is A, this is M, and this is B. Pretty lousy B. So let's try that again. There we go. Alright, now it says the length of segment AM is given by the expression 3x plus 8. So 3x plus 8. And MB is 6x minus 4. 6x minus 4. So, we're looking for the length of AB. Now, the only information we have are these two expressions, and the fact that this is a midpoint. Well, if this is a midpoint, the midpoint cuts a segment into two congruent pieces. So we know this piece is congruent to this piece. So I have an expression, 3x plus 8 equals 6x minus 4. That's all we need to do now is solve for x. So I'm going to combine my x's on the right-hand side because I don't like working with negatives. So we're going to subtract 3x from both sides. 8 equals 3x minus 4. I'm going to go ahead and add the 4. 12 equals 3x. Divide by 3. 4 equals x. Now that I have my x value, I'm going to go ahead and substitute that in for either one of these expressions. It doesn't really matter which, because this expression is equal to this expression. So I'm going to substitute the 4 in for x. 3 times 4 in this equation plus 8 equals 3 times 4 is 12 plus 8 is 20. So this gives us the length of AM. So this is 20, and if this is 20, this has to be 20, which makes AB 40. And that's problem 15. Now on to problem 16. In problem 16, we have find the perimeter and area of the polygon with the given vertices. So we have this four-sided polygon, a quadrilateral, that we're going to have to put in a coordinate grid. So let's go ahead and pull up a coordinate grid. And let's go ahead and plot these points to see if we can get some visual clue as to how to work this problem. So 5, negative 1 is right here. And then 5, 6 is here. Okay, so this is going to be x, which is going to be 5, 6. And y is 2, negative 1. So 2, negative 1 here. So this is going to be y, which is 2, negative 1. This one was w, which is 5, negative 1, negative. And the last point, z, which is 2, 6. So z is 2, 6. Okay, so nothing terribly exotic. We just have your basic quadrilateral here. So let's go ahead and draw in our segments as best we can. Okay, so there we go. Now, that's all we really have to do at this point. At first blush, it looked like we were going to need to do some distance formula stuff. But in fact, that's all we really have to do is some ruler postulate. So here, this distance, we don't even have to do ruler postulate if we don't want to. We can just count 1, 2, 3. That's the easiest way. But just for completeness, I want to use the ruler postulate, which is the absolute value of the difference. So 2 minus 5. We're taking the difference of the x coordinates. 2 minus 5 is negative 3, which is 3. So this segment length is 3. So we'll put a 3 in here. That makes this a 3 as well. And for this one, we're going to average the y's, or take the difference of the y's. So let's do that up here. So we have 6 minus negative 1. And it's the absolute value of this, which is 6 plus 1, which is the absolute value of 7, which is 7. So this is 7 and 7. So we're looking for the area and perimeter of the polygon. Well, our perimeter is simply going to be the sum of the sides. So in a quadrilateral, it's going to be 2, well, in a rectangle, this is actually a rectangle, it's 2L plus 2W, which is 2 times 3 plus 2 times 7, which is 2 times 3 is 6 plus 14, which is 20. So that's our perimeter. And our area is simply length times width, which is 3 times 7, which is 21. And that's all there is to number 16. Now let's move on to problem 17.